so for this one, again, first thing is to set your your equations equal to each other to try to find the bounds. So what you'll do is you'll set cosine theta equal to 0.5. So basically what you're doing to solve that equation is you're looking at the x coordinate on the unit circle and you're trying to identify where is that equal to a half. And that is going to happen up here at pi over 3. Now, you technically would also have that the x-coordinate is equal to a half below as well. However, if you look at the picture clearly goes between 0, or basically in quadrant 1. So you don't have to include quadrant 4 because if you look at the picture, you're looking at quadrant 1 only positive x values. So because of that, your bound of integration would basically start at 0 and it would go to this intersection point, and that intersection point happens at pi over 3. Now, you'll also notice that on the picture that they have given you, it continues until a little bit past this, and that's because they tell you that the bound goes from 0 to pi. So you would have 0, pi over 3, and then pi. And again, I unfortunately did not write that on the sheet here, but they do very clearly indicate it's from 0 to pi as part of the problem as well. So you'll notice here that you have a little bit of an unusual situation because it's not just two numbers. You're going from 0 to pi, but then they cross at pi over 3. So because of that, you have to think about what would this integral be, and then what would this integral be in terms of the big versus small. So you'll first start off with on 0 to pi over 3, identifying what the bigger number would be. So you're looking at y is equal to cosine theta, and then you're looking at y is equal to a half or 0.5. So somewhere between 0 and pi over 3, you need to plug in a number. So maybe you plug in like pi over 4. And that's going to give you square root of 2 over 2. And you're comparing that to the 1/2 where there's nothing to plug in. So when you look at that, you're going to notice, of course, if you just compare numerators, that the numerator here is bigger. So this cosine theta is going to be the big function, and then the small function will be the 1/2. So from this initial part, what we have found is that the first integral from 0 to pi over 3 will have a big function of cosine theta minus, and then a small function of 1/2. And of course, because we're using theta, we will have d theta as our integral of, or as our variable of integration. Okay, now that is just integral number 1. Now you have to repeat the process for the second interval. So for the second interval, you're looking from pi over 3 to pi, and again, you're trying to identify what the bigger function is. So on the pi over 3 to pi interval, you would look at your y is equal to cosine theta, your y is equal to 1/2, and plug something in. So you might plug in, for example, on this interval, pi over 2. And when you look at cosine of pi over 2, again, you're up here on the unit circle, your y value is 0. You're comparing that to y is equal to 1/2. So here you notice that the bigger function is going to be the 1/2, and then the smaller function will be the cosine theta. So when you have the bounds of pi over 3 to pi, your integral is going to look like pi over 3 to pi, and here your big function is 1/2 minus your small function, which is cosine theta d theta. Okay, so this is one of our integrals, and then we have to add that to the integral that we found for the 0 to pi over 3 bound. Okay, so here's what it's going to look like at the end of the day to find this area. You're going to be going from 0 to pi over 3 cosine theta minus 1/2 d theta, and then adding that to the second interval, the pi over 3 to pi, and then the 1/2 minus cosine theta d theta. Okay, so you do have to integrate them separately here. So when you look again, like the first one, your cosine theta is going to go to a sine theta, and then minus the 1/2 goes to 1/2 theta. And then the bound from 0 to pi over 3. You'll then add that to this integral where the 1/2 goes to 1/2 theta, and then minus the cosine theta goes to a positive sine theta, and then the pi over 3 to pi. Okay, now you can evaluate them individually. However, it might be better to just kind of treat it as one big interval and one big integral where you first plug in the pi over 3 minus sine of pi over 3. Okay, so that's my upper bound plugged in, minus, and then the lower bound plugged in, sine of 0 minus 1/2 times 0. Okay, that will then be added to the second interval where I go from pi over 3 to pi. So I'll plug in the pi upper bound first, and then minus the lower bound plugged in. So 1/2 pi over 3, and then minus the sine of pi over 3. Okay, now at this point, we're kind of hoping and praying that something is going to cross out or cancel out. So to start off, the sine of pi over 3, that is going to be equal to square root of 3 over 2. So let me write that on this next page, okay? So sine of pi over 3 goes to square root of 3 over 2 minus, multiplying these straight across, gives you pi over 6 minus, here's where something nice happens for us. The sine of 0 is just 0. This is going to 0. So that whole second term or second quantity completely crosses out. Then we go to the plus, the 1/2 times pi gives you pi over 2, minus sine of pi is also going to cross out because sine of pi goes to 0. Then we have our minus, the 1/2 times pi over 3 goes to a pi over 6, and then distributing here, you get plus, and sine of pi over 3 is the square root of 3 over 2. Okay, so now we just need to simplify these terms here. So you have a square root of 3 over 2 and another square root of 3 over 2. So if you add those coefficients, you're going to get 2 square root of 3 over 2. Here, if you look at your pi's over 6, you have a 1 pi over 6, another pi over 6. So that gives you negative 2 pi over 6 plus pi over 2. So the 2's will cross out here. You get square root of 3 minus pi over 3 plus pi over 2. And you'll want to combine those two like terms by getting a common denominator. So multiply by 2 over 2 and multiply by 3 over 3. So that gives us square root of 3 minus 2 pi over 6 plus 3 pi over 6. And then adding those coefficients, we get square root of 3 plus pi over 6.